Hey, what is up guys? Welcome to this live coding session, and today we're going to be looking at this wonderful animation. I found this animation at a lot of places, and I've particularly found this GIF somewhere stumbling around the internet, and what we're really going to try to do today is convert that GIF into code. And this is not going to be the usual tutorial video, but we're gonna be really talking a lot about the dynamics of this animation and how you would want to think when you're writing code for an animation. So we're going to be trying to code this in pure CSS, so there's no JavaScript that's going to be fiddling around here, and we're going to see how quickly we can do that. So a lot of the time that I'll be spending in this video is trying to understand this animation and the dynamics of the animation. So although the animations like this really look complicated, but if you're really understanding them and breaking it down into pieces, it's really a very simple animation. So let's try to figure out what's really happening here before we jump out and write some code. So how I see this is that there are cubes stacked within each other, and we are only seeing the borders of these cubes. So there's a cube in a cube in a cube, and so on. And then what's really happening is that these cubes are rotating at an angle, and not all cubes are rotating at the same time, so there's a delay. So the innermost cube starts rotating, followed by the cube above it, and so on. So essentially what we need is some cubes and the sides for them. So that's really the step one for us. So what we're going to do is build some cubes, and then step two is going to be to try and stack them within each other. And then step 3 is going to be to give them some volume. That means that our cubes are going to be in 2D, so we are going to transform them to look as 3D cubes. And the step 4 of this little project would be to rotate them. So let's see if we can get some cubes working, and we're gonna be coming back to this animation multiple times as we code to see and understand more of the dynamics and how you would really want to think when you're coding an animation. So we have I think done a pretty good job at breaking down the problem. So let's go on to the step 1. We're not going to be needing JavaScript. For HTML we're going to be using Pug, because Pug gives us this power where the HTML basically writes itself. So let's see, we need cube, and to build a cube we'll just it's just sides for us. So we are gonna build something called container, something called cube, which is basically container for our sides. And a cube is essentially going to have 6 sides, so we can have a class for that. So instead of building 6 sites or writing sites for 6 times, what I'm going to do is I'm going to use the power of Pug, and let's say we'll use I, we'll initialize it to 0, and we'll let it run until it's less than 6, and increment by 1 each time. And this time we're just gonna build something called side, but in the animation we have multiple cubes as well, so we are gonna have to put the cube itself on a loop. So let's see, we're gonna make another for loop here. Oops, we're gonna make another for loop here. So we're gonna assign, and for time being we're just gonna go with say 5 cubes so that we can understand the dynamics better, and J++. Alright, so I think we are pretty good. So what we have essentially done here is we have created a div called cube, and inside the div cube there are going to be 6 more divs for each side, and then this whole cube div is going to repeat 5 times to render our divs. Let's come to CSS. So let's give the body a little dark background. Oops. Yeah, so I think we should be able to start writing our sides. Okay, so when we go back to this animation, all we need, so each of these cubes has some height and width, which are basically same because it's a cube, and all we are seeing of this cube is borders, so it shouldn't be very hard for us. But in order to give different width and height to each of these cubes, we are really be using the CSS custom properties and custom variables because it's fun to use, and it really reduces the code. Okay, so all we need is height. So let's say we are going to build a CSS variable called edge, and then we are gonna need a width. So I'm just gonna wrap this inside a var, and then we're gonna need something called width. So that's going to be edge as well because it's a cube. And our sides, okay, so this is not cube, we are building side, and our side needs border because that's how we're going to see it. So the border can be 1 pixel. So because we have light, because we have a dark background, let's go with some light color. Okay, yeah, bingo. So we can actually see the sides of our cube, but they don't really look like cubes right now because we are using edge, but we haven't defined edge yet. So in order to define edge, what we need to do is we need to run a for loop and give a unique value to each of the side. Okay, so we need the number of cubes as well. So for that I'm going to define a variable here in CSS itself so that we can have it. Let's call it number of cubes. So let's take 5 now, and then we'll start a for loop, and then this for loop is essentially going to be from 1 to 5. So yeah, let's get that done. Oops. So we'll create an iterator. So iterator is going to start from 1 through our variable that we have created, and then what it's gonna do is it's going to give these cubes some width and height. So we're gonna go to cube, and we're gonna pick the nth child. So, and then nth is basically the ith in our case. So we are quickly going to pass on the iterator variable here, and yeah, that's pretty good place to define the edge, which is going to be let's say it can be I. Okay, and we have to give okay, so it looks like we have some sides appearing now, but these definitely don't. Let's give them size. So I'm just going to double them. Okay, but I think they're a bit too much. Okay, that looks perfect. So we have edge defined, but these sides are getting populated as independent elements. If we are gonna make a cube out of them, they should be really stacked. So because currently it is all 2D, and because our cube is going to be 3D, so we have to preserve 3D. That's going to be the next step, but let's position them absolutely so that they get stacked. Alright, so now the independent 6 boxes that we were seeing are actually stacked beneath each other. So I think it's good time that we move on to our container, which is the cube, and get things a bit more tidy. So we're gonna make cube, and let's get it to center first. So to get it to center, it should be easy. We're gonna give it top 50%, and then we're gonna make it go left by another 50%. And in order to these work, we're going to position it absolutely. Okay, bingo. So here we have it in the center, And now, because a cube is definitely going to be a 3D element, so we're gonna tell the browser upfront that you need to preserve the 3D. So for that, we're going to use the transform style property style, and we're gonna tell it to preserve 3D. It's not going to have an effect now, but when we actually do some 3D transformations, this is going to be key here. Okay, but if we look at the cubes here, if you'll just have a look at the outermost cube, because that's how we can build this whole animation by understanding the behavior of one cube, and the outermost cube is basically the easiest to do. So if you're going to look, it is positioned at an angle where it's really where the sides of the cube are pointing at us, and the topmost and the bottommost side, when it's pointing towards you, they are really at the same point. So we have to get that viewport, and in order to get that viewport, or in order to make this cube look through that camera angle, we have to transform it. So in order to do that, we can clearly see that the cube is rotated at an z-axis. So if I'm just going to show you, so if you actually use the rotation at z-axis, because it's almost 45 degrees, you can see that this is going to now point at you, but this really makes the plane of the cube look bad. So we'll have to balance this rotation with another rotation at an x-axis. So if I rotate it at an x-axis, say at 45 degree, you can see that it now looks more of a plane, but I don't think it's still flat enough to be the base of our cube. So we're gonna rotate. Yeah, that looks way better. So we have rotated this sort of plane of a 2D cube to look like how it's looking in the animation. So that could be a good step 1. So now we're going to move to step 2, where we're going to try and give this a bit more volume and get things looking more 3D. So in order to do that, there are a couple of interesting problems that we're going to have to solve here. The first is that in order to rotate it, we have to rotate each of the cube at an angle. So that can be done via the CSS custom properties, but what cannot be done via CSS custom properties is deciding at what degree each of these cubes needs to be moved, or each of these side needs to be transformed. And to help us with that, we will be using a library that is a very popular library called Compass CSS3. So if I'm going to quickly import this library, okay, so what this is going to allow us to do is to rotate the sides via vectors. So like if you're going to rotate it using degrees, then we have to find the exact degree at which we want to rotate, but the benefit that we get using vectors is really that these vectors independently don't mean anything, but when they work in relation, it auto calculates everything that we need. So all right, let's try to rotate it. Okay, so the first thing that I'm seeing that we need to do is bring these up a notch. So if you're gonna see here, the top end of the cube, the top edge of the cube actually the top edge of the cube is actually merging with the bottom edge of the cube. So in order to do that, let's see if we can do that. So if I just transform and do a Z translate, so Z translate is going to basically move it by the given value in the Z axis. So I'm just gonna do a Z translate. So to show you, if I do like 20px, so you can see it moved in the Z axis by 20 pixels. But what we really have to do is we have to move each of these sides via an unique value, but because we are using custom properties, we just have one side, so we are again going to be using the age variable, which is basically unique to each side. So let's see. So edge will be basically 1 2 3 4, so we don't want that much, so we'll just go with half of that value. So I'm just going to give 5, and then we have to use calc, of course. So 0.5 into the value of the edge. Alright, so you can see that each of these have now moved up, but the problem really is that the margins are now messed up, so we have to give a negative margin to basically counter for what we have just done. And this is really we're really doing this so that the camera angle becomes how it is in our animation. So we're just going to give it a negative margin. It's basically the same what we have done in translate, the negation of that. So edge. Okay, we are getting some error. Let's see where we have gone wrong. Okay, all right, that. Okay, so now you can see the top edge and the bottom edge are actually at the same point, so the camera angle is on point. Yeah, but if you see, if you consider this as a quadrant, we need to have this rotated in 3D 4 times. So that's this is if you rotate this quadrant 90 degree, it's going to appear here, and then we need a 180 and 360 degree rotation as well. And because we have vectors in place now, so it should be pretty easy to do. So we're just going to rotate this in 3D, and so rotate 3D is a method that accepts 4 parameters. So because we are using vectors here, it will be x vector, y vector, z vector, and the last parameter is actually the angle in which we want to rotate. So we would not want to touch the so we only need because we only need y rotation because everything else is on point already. So I'm just going to rotate it via y, and the angle. Okay, so each of these cubes will again have to be rotated individually. Okay, so if I rotate it at 90 degree, if I rotate all the sides at 90 degree, this is what will look. If we rotate it at 180 degree, we get down, and if I don't rotate, then it's on top. So we need to have 0, 90, 180 and 360 degree of rotations for each sides. So for that we need another variable that's going to help us decide that which index of side needs to be rotated at what angle. So let's calculate that. So another for loop, let's just call say angle, and then angle will start from 1 to 6 because these are essentially our cubes. And then let's capture it. Because we are inside the side, we can directly use the nth child here, and then our nth child is basically the angleth child, or let's call it something easy. Let's call it f, and then we're gonna capture it. So fth child is going to come here, so that's gonna be f. And because we don't want the first child to move because it's already in place, as we can see now, we're gonna go with f plus 1. Okay, and then we need a variable that's going to tell us our angle, because f is basically an iterator that we're going to use to calculate say m, which we can call, let's call it a for angle. And then yeah, so we need it to be rotated 4 times. So we're gonna just use an if condition to check if f is greater than 4, because these are all multiples. We can consider it as multiples. So if f is actually less than 4, that means if f is 1, it's going to be 1. So we're going to multiply it with 90, so that's how we're going to get 90. And then if f is 2, it's going to become 180, and then tilt forward it's going to be 360, and after that we would not need it, so we're gonna, so till this condition is true, let's return F, and after that we're simply gonna return -1. Okay, so it's time to use this angle. So how we're actually going to calculate this is, we'll see if we have M, otherwise we're just gonna pick 0, and we are going to multiply it with 90 degrees. Okay, it seems we're doing something wrong, and that's obvious because we cannot use variables like that. Okay, it should be all good now. Okay, so our rotation is 0 point now. Oh yeah, so this is the race to pick 0, so I think. Oops. Yeah. Okay, so I think, okay, it should not be M, it should be A. Okay, so alright, so we have the cube in place now. Sorry, we messed up a bit with variables here. So we have a cube that looks pretty good, so I think all that's pending is to rotate it. So let's see if we can rotate the cube now. So for that we are simply going to go to the, so we're going to give the animation property, let's call it, we'll create a keyframe. How about we call it rotate? Let's make it run for 3 seconds and ease. Okay, so it's time to, so let's create a keyframe. Yeah, so we'll create keyframes, we'll call it rotate. Okay, so at 0% we'd want the transformation to stay what it is now. So the initial transformation is this, and then if you see, these are actually rotating, so we're gonna make it halfway and then complete animation, and we're gonna rotate it. So we're gonna be rotating it at an X and a Z angle. So I think, okay, so if we look at the rotation at X isn't really changing, so it's only rotating maybe another 45 or 90 degrees on Z axis. So if we keep the X intact and actually rotate it, say at 130 degree, yeah, so but I think it really needs to be the other way around. Okay, so our cube is actually rotating now, but the problem is that all the cubes are rotating at the same time because there isn't any delay yet. So what we're essentially going to do is we will be introducing a delay that will be unique to each cube. So in order to do that, okay, so we will have to have another property that we can use to calculate delay. So because here we are already calculating a unique value, we can use the same for loop to calculate delay. Okay, so the delay can be equal to I, but I think it'll be a bit too much, but yeah, we can give it a shot. So if we keep the delay as I seconds, and we add animation delay here. So now what's really going to happen is each of these cubes are actually going to rotate independently. As you can see, it's happening now, but because it's a bit too much now, so let's try to reduce it. So if I reduce it by half, if I reduce the time by half, so this time is basically the delay between these cubes, between the animation actually kicks in for each of these cubes. So okay, let's put it at an loop. Okay, so now, but I think it's a bit too much. How about 0.1? Okay, so we have something going on definitely, but I think it's a bit too fast. I mean too slow still, so we're gonna fast things up. Okay, so we have something going around definitely. In order to understand it better, let's scale it up. So let's go from 5 to 30 cubes, and let's see. Alright, so we have the animation sorted out, and it's looking pretty good. The cubes are rotating, so I think what else we can do is probably make it look good. So instead of having a black background, we can give it a little gradient. Okay, so I looked up a couple of gradients, and this is what works best for us. So yeah, so all of these cubes are actually moving, and it's a pretty neat animation. So that'll be it for this video, guys. I hope you found it useful. We mostly went through what are the dynamics and how this animation actually works. And if you go back, we have actually written this in just about 50 lines of code, which again, as I said, that these animations do look complex, but once you have a hold of how the dynamics of that animation are actually working, it's not all that complicated to implement it. So if you like this, if you have any questions around it, drop them in the comments box, and definitely subscribe to the channel, because I spend a lot of time and resources to build these videos for you guys, and a good way to say thanks would be to hit the subscribe button. See you later.